Hi everyone, I wanted to do a little bit of a screen recording for the Math 300 pre-test in order to help assist with some of the prerequisite skills that you might feel like you're struggling with. So I'm going to walk through each and every one of the questions that I have assigned as part of the pre-test, and I'm going to go through a fairly thorough explanation with each step as we go. So if after this video you still want to get some points of clarification or if you want some extra help, please don't hesitate to come and see me. But we're going to get started with question number 1 here. In question number 1, the instructions say to evaluate the following. What that basically means is we want you to give us the numeric answer or the value for the expression that you see here. What this is going to require is an order of operations or rules that we always know as BEDMAS rules. So I'm going to put that acronym here on the right-hand side of the question. So when we look at that acronym BEDMAS, B stands for brackets. What that means is we have to do anything that we see inside a set of brackets first. So if I look at this expression, I see that 6 minus 8 is something that we can tackle inside those brackets. So everything around the 6 minus 8, I'm going to rewrite as it stands. So really we have 4 and 6 take away 8 puts us into the negatives, so that'll be -2 inside those brackets, all squared still, plus in brackets -1 to the power of 3. So we've taken care of the brackets in this case. E in our BEDMAS stands for exponents. What that means is we have to tackle anything with an exponent attached to it next in our sequence. I do want to remind you that there should only be one equal sign per line, and in an expression like this, you want that equal sign up front. So if we tackle anything with an exponent, we have rewriting that 4, but we have to tackle -2 all raised to the power of 2, or -2 squared. If you need to think about that as -2 times -2 again, we know that 2 negatives always give us a positive. So -2 all squared is +4, but we're still going to multiply that eventually by the 4 up front. Now, -1 all raised to the power of 3, in this case, be careful, you're going to have -1 times -1 times -1 again. 3 negatives maintain it as a negative. So we're going to add -1 times -1 times -1, which is really just -1 as a result. So we've taken care of the brackets and we've taken care of the exponents. The D is for division. M is for multiplication. And what I want you to note here is that division and multiplication are kind of the same rank. You would do division and multiplication in the order that you see it from left to right. So if multiplication appeared before a division symbol, then you would have to multiply first. Again, it's whatever happens from left to right. So in this case, we have multiplication up front. So 4 times 4 is +16. And I'm just going to combine the two signs here. We have a positive and a negative. So instead of thinking about adding a -1, I'm going to combine those two signs and say I'm really just subtracting 1. So we've taken care of our multiplication. We've taken care of course, there's no division. So we're on to our last two letters, which are A and S for addition and subtraction. Once again, that's going to happen in order that we see things from left to right. Here we only have subtraction, so we can finish this off and say 16 take away 1 is +15 as our final answer. Part B here deals with the same set of rules, or our BEDMAS rules, and we still want to start inside any brackets that we see. But when we look at these brackets this time, it's far more complicated. Inside the brackets, we have addition, we have multiplication, and we have a sneaky little power here, or an exponent that we have to deal with. So inside those brackets, we also have to follow the BEDMAS rules. So after brackets, we know we have to deal with anything attached or that has an exponent attached to it. So we're going to rewrite everything we haven't touched or used. So we're going to leave that 98 and divide by. In brackets, we're going to leave the 4 and the +5. And we're going to multiply that by 3 squared, and we know that's 3 times 3, or +9. So from here, if I look inside those brackets, I can see that I have addition with 4 and 5, but I have multiplication with 5 times 9. So in order, if in proper order rather, we have to do the multiplication step first. So everything we don't use, we rewrite. 98 divided by, in brackets, instead of 4 plus 5, we're going to multiply that 5 and 9 together and say that that's 45. So we're still working inside these brackets to clean up the mess, so to speak. We've got 98 out front. We're going to divide that by 4 plus 45, or 49. Now we've taken care of everything inside those brackets. That's proper order of operations. The only thing we have left to do here is division. Of course, 98 divided by 49 leaves us with positive 2 as our final answer. From BEDMAS rules, we're going to work on a little bit of algebra with example number 2. The instructions for example number 2 say expand and collect like terms. So by expand, we mean get rid of those brackets. In this case, I see 2 separate terms in one set of brackets, and I see 2 separate terms in a second set of brackets. So whenever you have what we call a binomial, so 2 terms, multiplied by another 2 terms, we have the acronym FOIL to help us decide what to do first or what to do last. So F in FOIL stands for the word first. What that means, what that means is that we are going to multiply the first term in each set of brackets. So that's the F. So if I take x and I multiply that by 2x, 2 times an imaginary 1 gives us a 2 up front. X times x is just x squared. So there's our first term. O in FOIL stands for outer or outside. So we're going to multiply x by positive 3. So x, so there's our O. X times positive 3 is a positive 3x. I stands for inner or inside. That means the 2 inside terms in those sets of brackets are going to be multiplied together. So in this case, it's a negative 5 because we pull the sign in front times positive 2x. So that's going to give us a negative 10 of those x's. L is for last, so that's the last set of terms. So in this case, we've got negative 5 times positive 3. Negative 5 times positive 3 is going to be a negative 5 times 3, or 15. At this stage, we're almost finished, but we have to collect what we call like terms. So if you have the exact same variable, you can collect those terms as like terms or combine them. So we have a 3x and we have a negative 10x that are like terms. I'm going to put everything else in what we call descending order of power. So we're going to have the highest x first, so that's going to be an x squared. So 2x squared is going to sit up front because that's the biggest power. Then we've got 3 minus 10 of those x's. So 3 take away 10 puts us into the negatives. That's negative 7, but again, they're still just plain x's. Last, we have that constant term of negative 15 or minus 15. Constant just means a number with no variables attached to it. So we've expanded or FOILed this out, and we've collected all of the like terms. So our final answer is 2x squared minus 7x minus 15. Our next example is falling under the same instructions. It says expand and collect like terms, but this time we don't actually use the FOIL process because I don't have 2 sets of terms being multiplied by another 2 sets of terms in those brackets. We have a single term out front, so there's your 3, that's being multiplied by everything that comes in the brackets behind it. So this is kind of what we call distribute instead, or the distributive property. What we need to do is make sure that we multiply 3 times n first. So 3 times n is 3 of those n's. 3 times 4n squared is going to be a positive 3 times 4 up front, so 12. Now we still have those n squareds. The rest of the terms that are written aren't being multiplied by anything. They're just being added or subtracted. So we just rewrite everything that we haven't changed or dealt with. At this stage, what we want to do once again is collect any like terms that we see, and we want to start typically with our highest power. Now, if you write this answer in a different order, that's okay. It's just typical for us to write with highest power first. So if I collect my like terms, I see that there are 12 n squareds and 3 n squareds. So 12 plus 3 gives us a leading coefficient of now 15 of those n squareds. If we look at the n's, you have positive 3 minus 10. 3 minus 10 is negative 7 of those n's. And the only constant that we have at the very end is negative 8, and that stands by itself. So our final answer is 15n squared minus 7 times n minus 8. Question number 3 gives us a different set of instructions, and the instructions use the word solve. Whenever you see that word solve, what it means is we want to know what the variable is equal to. So because our first equation is y, in the end, what we're trying to figure out is what y is equivalent to in order to make this equation balance. So we've got a little bit of work to do to get rid of brackets before we're ready to solve for y. The first thing I want to do is remove those brackets and see what our terms actually look like. So there's nothing for us to put together on the left side. Those are two different terms. And what I want you to notice is that I'm only putting one equal sign per line. So because this is an equation, that equal sign is in the middle where it starts. Now on the right side, we've got 2 times y. So once again, we have to distribute. 2 times y gives us 2 of those y's. And then 2 times positive 1 is a positive 2. So 2 times 1 is 2. At this stage, this helps us figure out what kind of equation or how many solutions we're supposed to have. This is what we call a linear equation. It means we have a single y, or a y to the power of 1. What that means is we want to get the variable terms to one side, so everything with a y gets to one side. Everything without a y goes to the opposite side. So I'm going to leave negative 4y on the left-hand side just because I'm used to having variables on the left. What that means is we have to move the 2y from the opposite side over. So in order to move things across an equal sign, you have to do the opposite operation. So technically we're adding 2y to the right side. So to move it over, we have to subtract it. So some of you will show your work by saying, I'm going to subtract 2y here, but to keep my equation balanced, whatever I do to one side, I have to do to the other side. So we get negative 4y, and we've got minus 2y now with and on the left-hand side. If you wanted to rewrite the rest of the equation and you only wanted to do that step, that's okay. We still have plus 18 on the left side, and we still have that positive 2 on the right side. If that bothers you and you want to move that 18 over right away, you're welcome to do that. So we'd have negative 4y minus 2y's. And then on the right side, we'd have positive 2, but when the 18 joins it, once again, we're subtracting 18 from both sides in order to balance this equation. So we got 2 minus 18. Now let's clean this up a little bit or combine our like terms. Negative 4 minus 2 more of those y's gives us a total of negative 6y. On the right side, 2 minus 18 is negative 16. So from here, the last thing we want to do is isolate y. Right now, it's negative 6 times y. So to undo that relationship, we're going to divide the left side by negative 6 to cancel it out. And we have to do the exact same on the right side. So we've got y equals negative 16 divided by negative 6. Now, this is an okay answer, but it's not really in reduced form. So we know that every time you have two negatives and you're dividing them, they become a positive. So we could say that our answer is positive 16 over 6, and that fraction can be reduced to smaller terms. Both of those numbers can be divided by 2, so we want to reduce that fraction. We would say a better answer would be 16 divided by 2, or 8. 6 divided by 2 is 3. So 8 over 3 is our final answer. Our next equation looks very different because all of a sudden we have an x squared. Whenever you see an x squared, this is something we call a quadratic equation. Every time you see an x squared or a quadratic equation, what we need to do is factor it first. We can't just shove the x's to one side and the numbers or constants to the other side. So we have to factor this first. Now, there are all kinds of factoring techniques. We focus a lot in this course on factoring a difference of squares or factoring common factors. But in this case, we don't have a difference of squares and we don't have anything that's common. So essentially what we're going to do is we're going to reverse the FOIL process. When you factor something like this first, you really have to think about the FOIL process in reverse. So when we FOIL something out, it means that we've got two terms multiplied by another two terms. If I were to expand that, I would get a quadratic equation that looks like what we see here, where we have three terms and all of them are slightly different. So what I want to do is think about what I can put in the first two positions that are going to multiply to give me x squared. So in this case, that has to be an x times an x. Now from there, I want to focus on the last term. It's a negative 18, so I know I'll be multiplying a positive by a negative to get that negative result. But I have to think about factors of 18. So it could be 6 times 3, it could be 9 times 2, or it could be, in this case, 1 times 18. But I have to be mindful that when I look at my middle term, I want to end up with a 3 times x. So in this case, the factors that work are 6 times 3. And I'm going to put a positive 6 and a negative 3. Now, when I teach students how to factor, I often teach them how to kind of check to make sure the middle term is correct. And I use something that I call a little smiles check. So if I create a baby smile here, 6 times x is positive 6x, and a big smile, x times negative 3 gives us negative 3 of those x's. If I were to combine those and take 6 times x minus 3 of those x's, I'd get a positive 3x in my middle term. And that's exactly what we want as our middle term for positive 3x. So I have factored this correctly, but I'm really supposed to solve this equation. So I'm going to move over and rewrite our factors here and say that x plus 6 times x minus 3 is the factored form, but that's still set equal to 0. And I'm trying to look for what x is equal to. Now, if those two pieces multiply together to give us 0, we can use something we call the zero factor property. What that means is x plus 6 on its own could be 0, or x minus 3 on its own could be 0. So now these just become little mini equations for me to solve. If I want to get x by itself, I'm going to subtract 6 from both sides, and I get x equals negative 6 as one of my solutions. In my second little mini equation, I can add 3 to both sides. So then we get x equals positive 3 as our second solution. The good news about solving equations, whether you get funky fractions or nice integers like this, the good news about solving equations is you can always substitute those answers back into the original equation and see if it makes the left and right sides balance. So for this quadratic equation, because it was an x squared, we ended up with two solutions, one of them being negative 6 and the other being positive 3. The last 4 examples here are asking us to factor the following completely. So there are different factoring techniques that we're going to be using. We have common factoring. You always want to count your terms and see if there is anything common across the board. So you can use a common factoring technique. We have something called a difference of squares. So when we see that in these examples, we'll focus on it. And then we have something we call trinomial factoring. Trinomial means you have 3 terms, and they could be general trinomials or they can be simple trinomials. But basically, trinomial factoring is the reverse of FOILing. So you're going to set up 2 sets of brackets and break those binomials down so that when we multiply them back together, we get the original expression we started with. So keeping those factoring techniques in mind, let's take a look at part A. We've got 3n squared plus 15 times n. There are two separate terms, but what we notice is that there's a 3 that's common or can be divided by or divided out through each of those terms, but there's also a variable n that's common. So what you want to do is put your greatest common factor out front, and then inside brackets, we're going to put what we call the leftovers after we divide that greatest common factor out. So once again, in 3n squared plus 15n, 3n is common. That's my GCF. So in my mind, I'm going to divide that first term by 3n and divide the second term by 3n to get all my leftovers. So 3n squared divided by 3n, we see the 3's cancel or divide themselves out. N squared divided by n still leaves us with an n. Now we move to the second term. 15 divided by 3 is 5, so we've got positive 5 or plus 5, and the n's divide themselves out as well. So this is the factored form of the expression 3n squared plus 15 times n. We could check it by expanding it or multiplying it through just to make sure that we have exactly what we're supposed to have when we expand in this expression. Part B is slightly different. We see y squared minus 16. This is something we call a difference of squares. Difference meaning there's a big old subtraction sign in the middle. Squares meaning that both y squared and 16 happen to be perfect squares. So perfect squares are two numbers or when you can factor something and those two factors are identical. So the number 16 is a perfect square because I could break that down as 4 times 4. So two identical numbers multiplied together give me 16. Anytime you see a difference of squares, you set up your two sets of brackets and you put one plus in the middle and you put one minus in the middle. It doesn't matter what order you see or what order you have. What I want to make sure of is whatever's sitting in this first position matches what's in the first position of these brackets. So in order to get y squared, we need to multiply a y by a y in that first position. Now, if I take a look at the number 16, I've got 4 times 4 to give us 16. And if we multiply a positive 4 by a negative 4, we get a negative 16 as a result. Now, some of you might be thinking about that SMILES check from a couple of minutes ago, but I want to show you how this SMILES check would work here. If I did a baby smile, 4 times y is positive 4y, and y times negative 4 is negative 4 of those y's. When we combine that, what we get is 0 y's in the middle, so there is no middle term. So we know that we have factored this correctly. And once again, that final factored form, or our final answer here, is y plus 4 times y minus 4. And if you put that in a different order, so if you said y minus 4 first and y plus 4 second, you'd be absolutely correct. It's the same answer. In part C here, we see 3 terms, a squared minus a minus 42. I don't see a common factor across the board. There's nothing common to all 3 terms. I don't see a difference of squares because in a difference of squares, I have to have 2 terms separated by a minus. So this is a trinomial that we have to factor. And essentially this becomes the reverse of the FOIL process. So if we set up our 2 sets of brackets here, I know that when I multiply those 2 sets of brackets together, I need to get back that original expression. So once again, I know that what we have to have sitting in the first position is an a times a to give us a squared. In the last position, we're looking for a negative 42. So these 2 terms have to multiply to give us a negative. What that tells me is we've got 1 plus and 1 minus. So in order to get 42, factors of 42 could be 42 times 1, 21 times 2, or 6 times 7. What we want to have in that middle term is an imaginary negative 1 of those a's. So if we think about 2 numbers to combine themselves and get that negative 1 in the middle, chances are pretty good it's a 6 and a 7. Now, I can only use this technique with ease because this is a simple trinomial. I have a single 1a squared up front, so it makes the factoring a little bit easier. So if I think about factors of 42 being 6 times 7, I'm going to make my 6 positive and my 7 negative. Once again, what we want to do is double check to make sure we did that correctly and check our middle term by using that SMILES check. So 6 times a is positive 6a. A times negative 7 is negative 7 of those a's, which gives us negative 1 of those a's in the middle, and that's exactly what we want. So the correct factored form would be a plus 6 times a minus 7, or if you swap the order, a minus 7 times a plus 6. Last but not least, we have another trinomial, 2x squared minus 11x plus 12. There's nothing common. It's not a difference of squares. So once again, we have to reverse that process and think about how FOIL works backwards. So if we need to have a 2x squared in the first position, we know that we have to multiply a 2x by another x. Now I skip the middle for a second and I focus on that last term. The last term has got to be a positive 12. So if I think about factors of 12, it's either 6 times 2, 3 times 4, or 1 times 12. Typically, if you're not sure, you should start with the two terms that are closest together. So I'm going to start with a 4 and a 3. Now, my middle term is supposed to be negative, so that means I have to incorporate negatives somehow. If I multiply two negatives, that'll give me a positive 12 in the end, as long as I do this correctly. So if I were to put, let's say, 4 up front and 3 in that second term, so 4 times 3, we're going to take a look and see if our SMILES check works out. So negative 4 times x is negative 4x, and 2x times negative 3 is negative 6 of those x's. What that gives us is negative 10, and that's wrong because we're looking for a negative 11. Now, it doesn't mean that 4 times 3 is garbage. This trinomial has a coefficient in front of the x squared that's not a 1. So whenever you have something bigger than 1 in your x squared position, you're going to have a little more trouble working out the factors because it's not as straightforward as a simple trinomial. So what I want to do is not throw away the 4 and the 3, but I'm going to change their position and we're going to show you what happens. Erase everything and we're going to start again. We're going to have our 2x times x. We don't actually have to erase the whole thing. I'm just going to erase that 4 and 3. We had them in wrong positions. So this time let's try the 3 in with the 2x and the 4 in with the just plain x. Now when we check our middle term, negative 3 times x is negative 3 of those x's. And 2x times negative 4 is negative 8 of those x's. Negative 3 minus 8 more gives us the negative 11 we want in the middle. So now we know we factored this correctly. Now that SMILES check can be a really handy thing. If 3 times 4 didn't work, we would have to try some other combinations. Maybe 2 times 6 would work, or maybe 12 times 1 would work. Again, it's a little more complicated when you have something other than 1 in the x squared position. So that made this a general trinomial instead of just a simple one, but the techniques are all the same. Start with your first term, move to your last term, and then do your SMILES check to make sure the middle term works. If you have any other further questions about this pretest, please don't hesitate to come see me. My office is always open and you're welcome to drop in anytime.